exciting.
Alright, I have some assistance for numbers 10 and 11. I'll sit back and watch them solve things. You can solve it at the same time if you want. Okay, so over here on the left, we copied down the problem, and we squared it. Because the square root's by itself, yeah. Square root's by itself, so we want to get rid of that square root, so we square it. But when we square one side, we gotta square the other one. Side stays the same. Then we add 5 to both sides. 2x is less than or equal to 30. Divide by 2. Not the 2x, just the 2. Leave the x. Yeah. So 2 divided by 2 is 1. That just leaves us with x is less than or equal to 15. Okay. Now, anything else that needs to be any other requirements? It's the part underneath the square root. This part underneath the square root can't be negative, or else then we're going to take the square root of a negative and we'll get an imaginary number. So if we want our answers to be real, really less than that, then we have to set the 2x minus 5 greater than or equal to 0. This should mean the part underneath the square root can't be negative. So 2x minus 5 needs to be greater than or equal to, that's less than. Slow your roll. Greater than or equal to 0. Here. So then we add 5. Get 2x needs to be greater than or equal to 5. And then when we divide by 2, we get x greater than or equal to 2.5. 2.5. So we have basically two parts of our solution. So x is less than or equal to 15 would lead you to believe that x could be anything less than 15. It could be all the negative numbers, it could be 0. But if you look at what happens when we plug in a 0 here, we have 0 minus 5, and then we're trying to take the square root of that. So the square root of negative 5, that's an imaginary number. Okay, and so then we're trying to compare an imaginary number to a real number. 5 is greater than or equal to the square root of 5i, and that doesn't make any sense. So this other restriction is what keeps us from, it says, yeah, less than 15, but it also has to be greater than 2.5. We can't let x get less than 2.5, because then we have negative numbers, right? Number 11. We got this. Here. All right. Okay, so less than or equal to negative 14. How are we going to get that square root sign by itself? That radical. Alright, divide by negative 2. So we got to think about what operations being done between the negative 2 and the square root. They're being multiplied. So we have to do the opposite of multiplying, which is to divide. Okay, what happens with an inequality when we divide by a negative?
It cancels?
Well, these will divide out, and then the inequality sign has to turn around. So we get square root of x minus 1 greater than or equal to positive 1.
7.
So now we're ready to square both sides. Squared. 49. I'm too lazy to erase it. Right over. 49. This is fun. 7 squared, 7 times 7, 49. Okay, then we add 1. Now x is greater than or equal to. Alright, any other things that we have to do? Any other restrictions? Part underneath the square root has to be greater than or equal to 0. So let's do like maybe over here. X minus 1 greater than or equal to 0. x greater than or equal to 1. Okay, so x needs to be greater than or equal to 50, and then this says x needs to be greater than or equal to 1. Well, this already takes care of that. So we don't have to write both restrictions now, because if x is already bigger than 50, like, we're not going to have a negative number for x, or a 0 for an x. So we always just check that, but sometimes we need to include it, like the first example, and then sometimes it's okay without it. 12. All right, number 12, we're going to get the square root by itself, just like we always want to do. And to do that, we'll move the 12 over, and we'll square both sides. We get 14 squared is 196 is greater than or equal to 3x plus 10. Subtract 10 from both sides. 186 is greater than or equal to 3x. Divide by 3. X needs to be less than or equal to 62. Okay, but then we have to check the part underneath the radical, because 3x plus 10, we're going to take the square root of that. We're going to take the square root of it. We need it to be greater than or equal to 0. So 3x is greater than or equal to negative 10. X is greater than or equal to negative 10 over 3. So we have two things here. X needs to be less than or equal to 62, but greater than or equal to negative 10 thirds. You can write that as a decimal if you want, but those are the requirements for x on this one. Okay, so we can have a negative number for x, but we can't have a negative number that's like negative 4. If we plug in a negative 4 here, we're going to be taking the square root of a negative, and we're not going to do that. Number 13. All right, having some fun with this one. Get the square root by itself, and there's a square underneath the square root. So crazy. So we add the 2 to the other side. 5 is greater than or equal to the square root of x squared plus 9. Square both sides. 25 is greater than or equal to x squared plus 9. All right, so there's a couple things that we could do here. We could move the 25 over, or we could factor it. We could subtract 9 from both sides, and we would have 16 greater than or equal to x squared. And then we take the square root of both sides. X less than or equal to, we'll do a plus or a minus 4. Positive or negative square root of 16. But then we could do a number line. We could do a sign chart. Negative 4 and 4. And let's look at our two zeros. So we've got x minus 4. I think this is easier to see if we factored it. X plus 4. So over here, if I moved the 25 to the opposite side, I would have 0 greater than or equal to x squared minus 16. I could factor that as x minus 4, x plus 4. So I got my two zeros there. Now, when we do a sign chart, I think it makes a little more sense. So negative 4, numbers less than that, negative 5. Negative 5 minus 4 is negative. Negative 5 plus 4 is negative. Negative times a negative is positive. But we want numbers that are less than 0. So we want negative numbers. So let's try 0, because 0 is in between negative 4 and 4. That would give us a negative and a positive, and those multiply to be a negative. Over here we'd have a positive and a positive. So our answers are between negative 4. Our answers are between 4 and negative 4. They need to be less than or equal to 4, greater than or equal to negative 4. And then the last thing, when we have a radical, is to check the radical and say x squared plus 9 needs to be greater than or equal to 0. So x squared needs to be greater than or equal to negative 9. And then when we take the square root of both sides, we get x needs to be greater than an imaginary number. Huh? What that just means is whatever number we put in here, we're going to square it, which means that this isn't really going to come into play. We're going to square all our numbers, and so a negative 4, once we square it, will become a positive 16. And so we're always going to be taking the square root of a positive number. And so this part underneath the radical doesn't really add any restriction. We're just left with x needs to be between negative 4 and 4. All right, you can turn this off if you are satisfied with your life, your mathematical life. I'm going to graph the first part. I'm going to graph 3 and the square root. So let's do 3 and then the square root of x squared plus 9 minus 2. And I'm going to go to the table. So we want to know when that y2 is going to be less than or equal to 3. So let's just go over here and look. Here's where it's equal to 3. And we want to know where it's less than 3. So where are my y values less than? Oh, stop going. Stop. And you can see right here, this is where at negative 4 and 4, my y values are equal to 3. And then in between, it's not my best work, in between there is where my y values will be less than 3. And so my solutions for x is from negative 4 to positive 4, but not including negative 4 or positive 4. Wait, yes, including. Yeah, including them because it could equal 3. All right. One more video for the constructed response.